Hello everyone. Today we shall discuss about operational amplifier, more commonly called as op-amp. So operational amplifier is a device which performs operations on the signals, certain operations like addition, subtraction, differentiation, and integration. And it also amplifies the signal. Therefore, the name is operational amplifiers. Means it performs addition, subtraction, differentiation, integration. Means it performs mathematical operations on the signal as well as it amplifies the signal. Therefore, combinedly it is called as op-amp. And the symbol of op-amp looks like this, which has two input terminals and supply voltages and one output terminal. And out of two input terminals, one is inverting terminal, which is indicated by negative sign, and one is non-inverting terminal indicated by positive sign. Inverting input and non-inverting input terminal. This is positive supply and negative supply. The transfer characteristics of an op-amp. If I draw it, it looks like this. Where we have a range A, O, B, and after this range, the op-amp goes to saturation region. And in this region, that is AOB, the output is directly proportional to input. Okay. So in this region, the op-amp behaves linearly, right? It means there is very little distortion of an amplifier output. And outside this range, okay, outside this linear range, then saturation occurs. It means the output is close to the maximum value. Either it is close to plus Vs or it is close to minus Vs. Next, we shall discuss about op-amp input modes. We have three input modes. One is single-ended, second one double-ended mode or differential mode, the third one common mode. As the name itself suggests, single mode means input is applied to one of the terminal. Okay, and the other terminal is grounded. Okay, either it may be applied to the inverting terminal or the input may be applied to non-inverting terminal. Okay, so in this case, input is applied to inverting terminal and the non-inverting terminal is grounded. In the other case, when the input is applied to non-inverting terminal, the inverting terminal will be grounded. This is called as single-ended mode. Okay, in the second case, double-ended mode means, as the name itself suggests, input here we are applying to both the input terminals. Input is applied to inverting terminal as well as non-inverting terminal. Okay, so this is called as double-ended mode. And the third one, common mode. It means input is applied, that is a common input is applied to both the input terminals. Next one, op-amp parameters. So some of the parameters are CMRR, means common mode rejection ratio. And the next one, input offset voltage. Output offset voltage. Input bias current. Input impedance. Output impedance. Input offset current. Then PSRR, that is power supply rejection ratio, or it is also called as SVRR. And then slew rate and bandwidth. So these are some of the parameters of op-amp. And now we shall discuss these parameters one by one. Look at CMRR. CMRR is defined as it is the ability of an amplifier to reject the common mode signals. So normally we say that op-amp is one which is needed to amplifier difference signal, not the common mode signal. So therefore, CMRR is the ability of an amplifier to reject the common mode signal. Check common mode signal. To reject common mode signal, has to amplify difference signal. We call this common mode signal as unwanted signal and difference signal as wanted signal or desired signal. So op-amp should amplify the difference signal and it has to reject the common mode signal. So we say that the higher the CMRR, if the CMRR value is high, then we say that the op-amp is a better op-amp. Okay, so in which the open loop gain is high and common mode gain is low. And CMRR is also defined like it is the ratio of open loop gain to common mode gain, and it is always expressed in terms of decibel. Therefore, we have to write it as 20 log of AOL, means a open loop gain, divided by ACM, means common mode gain. Coming to next one, input offset voltage. So ideally, output of an op-amp should be 0 if the input is 0. Means if you are not applying any input, then of course the output should be 0. But practically, we find there is some output. Okay, so even though we do not apply any input, there is some output which is occurring at the output side, output terminal. Okay, so what we have to do, we have to apply certain input, certain differential DC voltage, okay, at the input side to force the output to become 0. I'll repeat, when there is no input applied to the op-amp, theoretically we say that output is 0. But practically, when there is no input applied, we get certain voltage at the output. To make this output voltage 0, we need to apply a differential DC voltage at the input. Okay, so this differential DC voltage, which is required between the inputs to force the output to 0 volts, is called as input offset voltage. Okay, so this is the differential DC voltage which is required between the inputs to make the output 0. So this is called as input offset voltage, and it ranges in between 2 millivolt or even less than 2 millivolt. Coming to output offset voltage. Output offset voltage. So this is the actual value of the output. This is the actual value of the output voltage when the inputs of an op-amp are 0. Okay, so here in case of input offset voltage, what we say, when there is no input voltage applied, okay, there is certain output voltage. Okay, so that output voltage, when inputs are 0, it itself is called as output offset voltage. Okay, so this is the actual value or actual output voltage, actual value of the output voltage appearing at output terminal when there is no inputs or input applied. This is called as output offset voltage. Coming to input offset current. input offset current. So it is the difference of input bias current. Means we have two currents flowing at two input terminals, then input bias current is just the difference of I1 and I2. Coming to input bias current now. So input offset current is the difference of uh, these two currents flowing at two different input terminals, and input bias current is the average of the two currents, I1 plus I2 divided by 2. This is called as input bias current. The next one is SVRR, or is also called as PSRR. SVRR or PSRR. So SVRR means supply voltage rejection ratio. PSRR means power supply rejection ratio. So SVRR is the ratio of change in op-amp's input offset voltage to the change in supply voltage. Okay, so this is the ratio of change in input offset voltage to the change in supply voltage. Okay, so just now we defined input offset voltage. So what it is? It is the voltage, differential voltage, which is required to make the output voltage zero when there are no input applied. Okay, so PSRR means it is the ratio of change in input offset voltage to the change in supply voltage, and it is expressed in microvolts or volts or decibels or dB. Next one, slew rate. So it is the maximum rate of change of output voltage in response to step input voltage, or we can also define it as it is a measure of how fast the output can follow the input signal. Okay, so if I draw this in terms of figure, if I represent two signals now, one is input signal and one more is output signal. So the blue line is the input signal and the red line is the output signal. Okay, so it's a measure of how fast the output can follow the input signal. Actually, this is input signal and this one is output signal, right? So this slew rate means it is the measure of how fast the output can follow the input. More parameters like open loop gain. So open loop gain of an amplifier is infinite, and input impedance okay. So input impedance means it is the ratio of input voltage to input current, and it is also infinite. Ideally, we say that open loop gain of an op amp is infinite, input impedance is infinite, and output impedance, which means the ratio of output voltage to output current, is 0. And bandwidth, bandwidth should be infinite. It means it can amplify any frequency signal from DC to the highest AC frequencies. Okay. So these are some more parameters. Open loop gain is infinite, input impedance is infinite, output impedance is 0, and bandwidth is infinite. The op amp should have 0 noise, and just now we discussed about CMRR, and it should be higher, or we say that ideally it should be infinite, and even PSRR should be infinite. So these are some of the parameters of op amp. Now coming to its applications, the first and foremost application is inverting amplifier. So we have certain applications like inverting amplifier, non-inverting amplifier, and then voltage follower. These are some of the applications. And then adder, subtractor, then integrator, then differentiator. So we shall discuss about inverting amplifier and these applications in the next class.